off nicely. So with a question like this one, right? This is let me just maybe do this. With a question like this one, we know we're dealing with K. Right? K is what we're working on. One is somewhat straightforward, as we have just shown right now. We worked it out here. But then the second one, it says prove that the sum of the circumferences of the first 6 circles is equal to that. So your job is to firstly keep in mind that you're just going to use an SN formula. And then N is going to be a 6. You already have that given. You don't even have to worry about what they're going to end up with. So since you already know that you need an SN formula, the next thing is you need to find out which SN formula. Is it going to be for geometric or is it going to be for arithmetic? You see, because if you can just answer that question, you are practically done. You see, so answering that question, you would need to keep in mind that if they're asking you to prove that the sum of the circumferences. So if you're going to prove that the sum of the circumferences of the first 6 circles is equal to this, it means that your sequence has to have circumferences of these different circles. You see, so already the circumference of the first circle, the formula is just 2 pi r, right? And then the second one is just 2 pi r. Okay, let me not put formulas. It's gonna be a bit crazier to look at it that way. But remember, we said that the diameter is being halved every time. Well, but let's keep it simple and not do anything too complicated. If you're gonna work out a sequence for the first 6 circumferences, your job is, if you want to find out if it's geometric or arithmetic, well, chances that it's arithmetic are very slim, but we have to be sure. You see, so we have to get a proper value for r. So what you're gonna do is you may wanna write out the sequence a bit. So the first term, you know that you need to get the circumference of the first circle, and the circumference of the first circle we can get it by using the formula 2 pi r. And we can use this as our value of r in our first term, you see. And then the logic here is, you see that the first term, the first circle has this as the value of r. The next one, do you see that the value of r keeps getting cut by 4?
By 4?
I mean, in half, sorry. The value of r keeps getting cut in half. You see, so the value of t1, you're gonna use this r. The value of t2, you're going to use pi r squared as well. I mean, you're going to use 2 pi r as well, but your value of r is going to be half of that one. And then the third one, you're also going to use 2 pi r, but the value of r will be half the previous one. So the logic behind that, you could just say something like t1 is going to be 2 pi, well, technically r. The next one is 2 pi r over 2. The next one will be 2 pi r over 4. Going on and on and on. Because the original radius is what's being affected. If you look nicely, this is the original radius. Let's say it's r. This one here is half of r, right? You see that? But then, do you see that the one after it is going to be a quarter of the original one?
Yes, I understand that, but
yes.
Can you go back to the
Yeah, what?
Can you go back down to just go a little bit down? Okay. You see there where you say 2 pi r, right? Where did the 2 come from? Because don't you just say t1? Isn't it easy to just say t1 and then comma t2 multiplied by a half, t3 multiplied by a half? Why including the 2?
Well, this is just the formula of the circumference of the circle. Remember circumference of,
let me write that down.
yeah, this you need to know because it's a basic formula and we need it.
Okay, so it's 2 pi r. Okay, got it. I get it. Yeah.
So let's see here. Let's see. Yeah, so from here, we said here, you see 2 pi r over 2, 2 pi r over 4, going on and on and on. So that now you can easily work out what you may call your first term, second term, and third term. But the thing is, logically speaking, right, you should be able to see that this is the kind of a sequence that is not necessarily arithmetic. You're not necessarily removing a specific number.
Yes, because you're multiplying by a half.
Yeah, you see, because you're yeah, technically speaking. So with all that being said, we already know that our value of r, oh wow, this is we don't want to mix up the r's now because we're thinking of, if we're thinking of a geometric sequence, we know that Sn is equal to a r to the power of n minus 1 over r minus 1. So we need to be careful here. Let's maybe label it R2. R2 is going to be equal to T2 over T1. Is that correct?
Yes, it is correct.
Yes. So the first term, well, let's just put in figures inside this formula. Inside this formula, we would have put the 2 pi with R, which is 256 over pi. Here would have put in 2 pi square root 256 over pi, the whole thing over 2, right? And then this one, well, we don't need the other one. Let's just do this one. If we're gonna do this one, this we can just say 2 pi with the square root of 256 over pi, the whole thing over this would cancel out. And then here, if you have this as the denominator, you'd have pi square root of 256 over pi. And then the logic tells you that this cancels that, this cancels that, your answer is a 2. Okay, perfect. So since we know it's geometric, we don't have any issues because T1, we already see what it is. It's just this value. But then 256 is 256 a square number? Seems a bit fishy. Is it? Probably isn't it? Let me just double check. 256. Wait, yes, it is a square number because square root of, 16 squared is 256. So to make calculations easier, this you can write it as 2 pi. Square root of 256 is just a 16. And then square root of pi is just square root of 5. And just write it like that. Meaning this first term, you can write it a bit better for the sake of you being able to perform calculations easier. You see, so this looks like you can then write it as 2 pi times 16, which is technically 32 pi over square root of pi. If you want to take it further, remember, this is like pi. This is to the power of 1. Remember, anything under a square root, what if you want to write it with an exponent, what do you write it as?
Negative 1.5. No, negative a half.
Yes, to the power of a half. So you see, if your bases are the same and you're dividing, what do you do to the exponent?
If the bases are the same, you're dividing. you minus
You
the
minus what?
denominator, you minus the denominator per exponent from the numerator's exponent.
Yes. So here you can just say here you can write it as maybe to the power of a half so that it's a bit visible. So that here you can just have 1 minus a half is just a half. So you can just write it as 32 square root of pi here. So 1 minus a half leaves you with a half. So if you want to have pi to the power of a half or pi under square root, it is up to you. They are both 100% correct.
So that's where he got his 32. Okay.
Yeah. So with that being said, this is what our value for T1 is. You see, that's our first one. And this is also to show that you need to simplify your expressions as best as you can before you start before you start throwing them into formulas and everything. Always simplify them as best as you can. You won't go wrong if you do that. See, so here, let's see what we need. We need where is this thing now? Wait, yeah. So for this one, we need what's that thing, man? We need to see what information we have, right? So R we have, and this age 6 terms. A we work it out to be 32 square root of pi, and then that's R here, which is going to be our value for R in our formula. We have it. I don't know how I write it. I don't know. I'm writing it again. Sn is what we're looking for. You see, so we can just throw our values into our Sn formula. Let's write out our Sn formula. Let me use maybe a bit darker color. Sn is equal to A R to the power of n R minus 1. So here it's going to be square root of 32 square root of pi. R here is going to be 2. N is going to be 6. It's going to be 2. So here 32 square root of 11. All this are rather, why am I saying 11? Square root of pi, bro. So yeah, all this I'd much rather just put it in the calculator, because why not? This is gonna be 64 minus 1, which is like 63. I hope, but I shouldn't be playing games like that. The calculator should be
down.
Okay, I did it. Slow down.
Okay, so we said that our R is a half, right? Right? Why are you writing 2?
Wait, R is a half.
Yeah, isn't R half because because it's getting smaller and smaller and smaller by a half.
Oh, you're right. What mistake did I make here now? Oh, I took the first term divided by the second one instead of doing it the other way around. Oh, sorry. R would have eventually been a half if it was the other way around. If you take this divided by this, it would be a half. Yes. Excuse me. Apologies. Apologies. To the power of 6. There we go. There we go. Yeah.
Let me just
then this just means that this also will be a different value. This will be like 1 over 64. Yeah, I think then from here you would then just need to put everything in the calculator.
Okay. Let me just write that down.
Sleep, I'm coming.
What's happening now?
Oh no, my brother is just calling for my mother.
No, I meant like, should we carry on?
Okay. Yes, we wait, no, we can't. Let me okay, so does it prove that, right? That equation will be equal to the equation that they gave us on our question.
Yeah, so carrying on to get that.
So must we just put it in the, yeah?
Oh yeah, I see your point. Because yeah, anyway, so what we can do is we can just try and see how far we can go. Because fortunately here, you see 32 divided by a negative a half. What does that give you in the calculator? It's gonna give you a 64, a negative 64 actually. You see, so we can carry on from there. From here, this divided by the bottom is gonna give you a negative 64. And then from there, what do we do next? Yeah, so from there, the square root of pi still remains there. Nothing has happened to it. It's still where it was. And then moving on, we would then have in brackets here, 1 over, this we can maybe leave it as, here what you can, I think for us to end up with what they have, right? We can leave this the way it was. We can maybe say 1 to the power of 6, which is a 1, 2 to the power of 6, which is just 2 to the power of 6. So that's what we can write the stuff inside the bracket as. You see, we can write it as 1 over 2 to the power of 6. Do you see that? Do you see it? No? Yes?
Oh, I see it. So are you going to convert the 2 to the power of 1 over 6 into a negative so you can suit the question?
Yeah, all that's going to happen here is this goes up here. So let's just do that as the first step. And then you see the one that they gave us here has a plus 64. So for us to get a plus 64 here, do you see that inside here, they took out a negative, you see, because the 1 is initially a negative and then the 2 is initially a positive value. So if you take out a negative inside here, you're going to have negative 64 outside, right? But then if you take out a negative, here this becomes a negative value, this becomes a positive value. Do you see?
Yes.
Yeah, and then this outside is just going to be 64 square root of pi 1 plus 2 negative 6. There you go.
I have a question. I see why you did that, right? But it still is not going with the question though. Where
Yes,
it
still what?
It says 1, no, it doesn't say 1. It says, yeah, it says 1 minus 2 to the power of negative 2 for the final answer for that bracket part.
1 minus?
Yeah, it says 1 minus, so it's 64, square root pi, open bracket 1 minus 2 to the power of negative 2, close bracket.
Yeah, it does. It does. It does. And just because of that, I'm actually, wait. Okay, it's either there's an error or we have to double check our steps. But then judging from the steps, it doesn't look like there's anything wrong. So yeah, I would say that's maybe a typo in the textbook, because there's no other way. Unless in the one that you did, you got a minus.
The one when I did with the teacher, he did it ended at the same as the one in the textbook. So,
Oh man. I mean, I guess that's fine, but let's see. Let's see what we did then. So from the top, we got, so the 32 is fine, the 32 pi is fine. The a half to the power 6 minus 1 is fine. And then a half minus 1 is negative 1, negative a half. 32 divided by negative a half gives you negative 4. Yes. And then this. Oh, wait, no. If you take out a negative here, no, I made a mistake. It's just a sign error. I don't know what I'm thinking. If you take out a negative here, this becomes a negative. Because the negative is out. Remember, it's initially a plus. So it's just a sign error.
okay.